from around the globe. It's theCUBE, covering Space and Cybersecurity Symposium 2020, hosted by Cal Poly.
Welcome to the Space and Cybersecurity Symposium. Today we have our special guest, Bill Carlin from AWS. Bill, can you tell us a little bit about yourself?
Hey, thanks, Paul. I'm Bill Carlin. I'm a senior manager for AWS Ground Station. I'm responsible for sales and business development around the world. I've been with AWS for about a year, and I'm really enjoying myself in my role here, expanding Ground Station.
That's great, Bill. And we're really happy to have you here today for this event. Can you tell us a little bit about the primary factors driving Ground Station virtualization?
As you're probably aware, Ground Station infrastructure itself is pretty bulky, pretty hardware-oriented, or at least traditionally has been. It's expensive. And in LEO applications, that is low Earth orbit applications with multiple satellites, you need a variety of locations in order to continually access your constellation and to control your satellites and to receive the data that they're collecting or relaying. So there's been a continued emphasis on reducing the cost of ground station operation going back now for some time. And AWS, we realized very early on that there were significant data or volumes of data being generated by space-based collection, relay, and observation. And we realized that, gee, there's a great opportunity here to effectively virtualize ground segment by co-locating ground network facilities with our data networks and offering our clients the ability to fly and downlink from their satellite constellations through us in a very transparent fashion, and essentially eliminating all of the CapEx requirements, or at least a significant portion of the CapEx requirements around building a ground network. And so you kind of faced with the prospect of, okay, that's great, but why do you want to attach it to the cloud? And really, cloud computing, and specifically high-powered computing and machine learning, are driving a lot of the satellite data market. So folks are really interested in being able to collect their data frequently and in volume for the quickest possible retrieval and analysis. And moreover, to be able to do that from multiple sites around the world in terms of collection, and potentially multiple sites in terms of analysis, depending on where their operations are and where their client operations are. The other aspect is you want to do all that, and you want to do it very quickly. So you want low latency through this, if you like, latency budget. That is downlink from the satellite to the ground segment, interconnection or relay of that data to the appropriate data facility. And we do that through our global direct connect high-speed fiber optic network. And then to be able to then process it quickly. So it's about getting it down quickly, moving it to the appropriate location quickly, and then delivering it to the facility where all the downstream processing is going to take place. And then you want to be able to do it in a scalable fashion. You want to be able to say to the startup, you can do this if you have one satellite, or to the synthetic aperture radar constellation with 20 or 30 satellites, that we can do all this in the scale that's appropriate to you. So you're not basically saying to a startup, hey, you need $100 million to get going. And conversely, you're not saying to a well-established company that, gee, can you bear patience while we scale up for you? The cloud gives us the ability to scale, be elastic, if you like, in all directions, up, down, and sideways.
So that's a really good point. So, you know, the customers really can pay for what they use, just like the cloud is, right? But we're looking at in a ground station view for that.
Right.
So the same idea.
Our basic tenets are always to have our services work in a transparent model that are pay-as-you-go, scalable, elastic, and agile, and highly, highly secure.
So when customers want to use your ground station network, whether they're accessing data for downlink or, for example, getting intelligence from imagery data, how do they actually do that?
So the basic premise is that you're a cloud user, and we start with you having an AWS cloud account, and from that cloud, that console, that user console, you can access the AWS Ground Station service directly. You can configure what we call a cloud formation template to set up your services, both with respect to TT&C side and flying your satellite, and pulling down telemetry from the satellite operations, and from the downlink side to schedule passes over the relevant Earth station facilities, ground station facilities we have arrayed around the world. And you can do that in a variety of fashions. You can do it manually, one by one, if you're just a small operator with one or two satellites, or you're infrequently collecting. Or you can automate it if you're a large scale operator who has many satellites to fly and lots of data to downlink against a variety of customer applications and demands. But it all starts with an AWS account.
That makes everything much more flexible than it has been in the past.
Right. So for traditional operators who want their own missions operation software, we have an API, or application programming interface, that allows you to interconnect that. So we become an extension of your own mission software. Or if you want us to be that primary access point to your satellite, which we see often with scientific or academic applications, we can do that too.
Can you talk about use cases specifically? Anything around Earth observation or other technologies, synthetic aperture radar or IoT?
As I kind of led off with, the real differentiating or discerning value here is in the ability to not just bring it down in a transparent pricing model, it's to be able to bring it down frequently, effectively, continuously, and to act on the information you're collecting quickly. So if we look at use cases like, for example, Maxar, who biggest provider of satellite imaging in the world, they're tasked with a variety of imagery missions every day. And so some of them may be continuous, and it's more of a, let's see how things change over the course of a few days, a few weeks, a month, a year, etc. Other of them may be very specific, where they want to look at something in as real a time as possible and as frequently during the course of the day as possible. We just went through a use case with Maxar, wrote a blog post with us where they were able to take the image, downlink it, and complete the image restoration and delivery to customer in 55 seconds. Compared to compared to previous models where physics are physics, right? You can take the image and you can downlink it, but getting it from the downlink point to the actual reconstruction point, the image, the analytics point, the machine learning point, where are you going to take that information and compare it to the previous photo you took or image you took? That could be, in some cases, certainly minutes, if not hours, and in more than a few cases, days. So the AWS cloud infrastructure being deployed across 24 different regions around the world, all interconnected by 100 gigabit fiber optic, gives you tremendous scalability in terms of the delivery of low latency information.
Sounds like a lot of opportunity there.
So another interesting use case is in the area of Internet of Things. And I'm personally fascinated with this because there is so much opportunity for leverage here. Internet of Things is proliferating now terrestrially. All of the major mobile network operators are building out Internet of Things models inside their 5G deployments. There's a growing school around extending 5G into non-terrestrial architectures, including satellite. This gives you a nice standardized roadmap towards IoT via 5G, via satellite, which would enable, again, this concept of the hybrid network where you can have data collection on a terrestrial network and data collection via satellite, and you can unify all of it in the cloud. There are a number of satellite IoT service providers in existence already, And they are effectively operating in a couple of ways. And we're working with some of these new entrants on either store and forward models where they collect data from either the sensor itself, which are deployed in the thousands and eventually in the millions, or these sensors aggregate to a satellite terminal, which relays to the satellite. Satellite stores that information and then forwards it down to the collection point, the Earth Station, ground station facility as it flies by. There are IoT models that are built around things from very narrowband, super narrowband applications, literally light switch on and off, pipeline pressure, good, bad, gas pressure, good, bad, security doors, fences, things like that. And as the satellite flies by, it's just collecting the information continuously. This is an example of what I referred to earlier as the high contact type network. This is where the case where you want to be able to sweep up, if you like, that information continuously. So the more ground segment you have to collect these inputs, the more you can do, you can act on it and do with it. If you miss it, there'll be another contact in a short time. But it's less sensitive to the absolute need to contact and download than it is to the frequency of possible contact.
So are your ground station capabilities generally located close to where your regions are?
In general, what we're trying to do is essentially co-locate the ground network with our cloud network. The idea being, if we do that, we effectively put everything from the satellite down, except the satellite itself, in the cloud. The security advantages are enormous. The availability and diversity of resources available to protect and make sure those links are continuous is significant. And again, because the delivery point is the cloud, our ability to act on that, take and act on that information, or rather have our client take and act on that information, is immediate.
So the cybersecurity capabilities the cloud has today, which are good, apply almost directly then to data that's downlinked from satellites through the ground station network, correct?
Right. We're building our security architecture inside the standard AWS security architecture. So as I say, from the Aperture point, the antenna point back, the client and the client's data are effectively in the cloud, protected inside that model.
And do you use a shared security model with the ground station network like you do with the cloud?
We do in terms of the basic configurations around applications and application security. If you have an issue with an S3 configuration, for example, when you move your data from, in our case, the receipt point is EC2, the elastic computing point, you move that into S3, and if it's not properly configured and it can leak publicly, then there's a problem. But we work obviously very closely with our customers on their applications requirements and the resulting security requirements.
So Bill, are there virtualized ground networks that are optimized for specific types of satellites, or are they all open?
So there's a variety of applications, and ground segment is variable by bandwidth and by orbital plane requirements, things like that. Our approach has been to take the more difficult of the configurations and work to that first. So we've built a network that does a really good job of supporting low Earth orbit applications in inclined orbits. That is, orbits that don't rotate around the poles, but rather are at an inclination to the equator, passing over the most populated portions of the Earth, and by extension, the most desirable portions of the Earth to either monitor, surveil, or potentially communicate with. So in our approach, our first primary set of applications that we optimize for are around Earth observation. That's specifically imagery and synthetic aperture radar mapping, which are pretty highly intensive data formats and high data size formats. So maps are big, images are big, and when they're continuously captured, the resulting data volumes fill up, if you like, the satellite caches pretty quickly, and they require frequent download. On the opposite side of that same concept or construct, we're optimized for collection of narrowband data, things like ship signals and airplane signals that are transponder based or radio signal based, where the satellite can track them. They're not particularly large file sizes, but they are continuous. And so the network you kind of need there is one that's widely dispersed and has a lot of sites, so that over time, your satellite's going to pass over a collection point fairly consistently and often during the course of the orbit and the orbital day, so that the information they're collecting frequently is used, captured, analyzed frequently. There's really no point in collecting information frequently if it isn't collected frequently, because then you can't really differentiate between what happened an hour ago and what happened 5 minutes ago. So we have sort of looked at our network in the construct of both high data volume and high frequency of contact. And the virtual network concept really optimizes for, if you like, the ubiquitous network, the one that touches or communicates with your satellite frequently, but also handles large volumes of information quickly and gets it to where it needs to go quickly.
It seems like there's a lot of application here, especially in areas like emergency response, whether it's responding to a hurricane or a wildfire, right. Those kinds of things where you need data pretty quickly so right. the emergency responders can respond.
Yeah, so we're working with a number of weather imaging companies who are looking at your sort of traditional weather collection models, like NASA, like NOAA, for example, and other international weather agencies. But there are also a number of really interesting startups working in the hybrid weather information collection market, where they're collecting weather information off the ground and off the satellite. And again, it's a lot of information to process. It's all cloud-based. When you can have two different transmission networks, a terrestrial one and a satellite one, feeding both into the cloud, unifying your data collection, your analysis in a really timely fashion, that's a very powerful platform.
So where do you see the future in ground station looking like?
So if you take a look at what's coming up in the next couple of years, Paul, of scheduled launches and folks that have filed for licenses and work filings and other things around the world for LEO. And let's just exclude, for example, SpaceX and Kuiper and 10 to 15,000 small sats just for broadband. We still have another 10,000 plus Earth observation, climate monitoring, imaging, radar mapping, signals collection, satellite platforms coming up. And so in turn, the volumes of data that they're going to generate are significant. So left alone to itself, just the idea of cloud-based capture of all that data is pretty interesting. Marry that to the fact that you just eliminated a significant amount of CapEx for any new company entering that market, and now that they can focus that capital on their applications development and on customer acquisition, other things that have high value. That's pretty enticing just as a base model. But take that though and think about the things that you guys are looking at Cal Poly and the rest of the forward-looking community, where we're going to look at building all kinds of capability in space. We'll have storage in space, we'll have cloud in space, we'll have an internet in space, we'll potentially have lunar networks to build, so to enable lunar habitation. And that's sort of a stepping stone to deeper space and other planetary exploration. When I was a kid, I used to think I wish I'd been born 50 years earlier so I could have seen World War II and the Cold War and all these other things that I kind of touched peripherally but didn't live. Now I wish I was born 50 years later so I could go to Mars, so I could potentially see what it's like for the human race to actually move off the planet in scale.
Yeah, it seems like the next 5, 10, 15 years are going to be pretty exciting in the world of space exploration.
Yeah.
So really excited to hear all the work that that you're doing at AWS around the ground station and the aerospace and satellite division. Some really, really exciting things happening.
Yeah.
Thanks for your time today, Bill.
Thank you very much.